Have you ever stopped to think about what's really in your drinking water? I'm not talking about the stuff you can see. I'm talking about the invisible chemicals that can slip right through our traditional treatment plants. Well, let's dive into a pretty revolutionary new idea for fighting these hidden pollutants, and it all comes down to the incredible power of tiny, collapsing bubbles and a little bit of light. So, what are these hidden dangers anyway? Where do they even come from? The answer might actually surprise you, because the source is something we all use every single day. All right, that brings us to our first big topic, the invisible threat. We're going to break down what these pollutants are, where they're from, and why they are such a massive problem. You might think it's all about giant factories, but look at this. These contaminants seep into our water from farms, from the tires on our cars, and even from the soaps and shampoos we wash down the drain every morning. Seriously, they are everywhere. These things have a name. They're called micropollutants. And the key word you got to remember is persistent. They're designed to be incredibly stubborn. You see, unlike a lot of other waste that breaks down over time, these chemicals, they stick around for a very, very long time. So what's the real-world impact of all this stuff? Well, take a look at this number. According to one study, exposure to toxic pollution in our air, water, and soil is linked to an estimated 8.3 million premature deaths every single year. That is just a staggering number, and it shows the scale of the problem we're up against. And that huge number translates directly to our health. When these micropollutants make their way into our bodies, they can cause a whole cascade of serious problems, from kidney failure to severe intoxication. This isn't some abstract environmental issue. It's a direct threat to human health. Which, of course, leads to a pretty obvious question, right? If these pollutants are so dangerous, why can't our current water treatment systems just get rid of them? Well, as we're about to see, this is where the real challenge begins. It's not like we don't have ways to treat water. I mean, we have a whole arsenal of technologies, everything from simple sand filters to advanced chemical disinfection. You can see a bunch of them right here. But when it comes to tackling these tiny, stubborn micropollutants, all these traditional methods have a critical weakness. To put it simply, our old toolbox just isn't built for this job. Methods like adsorption, that's basically using something like activated carbon to trap pollutants, they don't work so well because these chemicals are just too slick to get captured. Membrane filters, they struggle when you try to scale them up from a small lab to a whole city. And other methods, like coagulation, can actually create new problems like toxic sludge. The bottom line is, we need a whole new approach. And this is where the science gets really, really cool. This next section introduces the incredible solution researchers have come up with, a super powerful combination of two advanced processes. So instead of just trying to filter or catch these micropollutants, the researchers asked a different question. What if we could just completely destroy them? What if we could hit them with a powerful 1-2 punch that just rips them apart into harmless little pieces? And here are the two fists in that punch. First up, you've got hydrodynamic cavitation, which, believe it or not, harnesses the insane physical force of collapsing bubbles. And then, for the knockout, you have photocatalysis, which uses light to trigger a chemical attack that finishes the job. So how in the world does this actually work? Let's step inside the microreactor and see this thing in action. To understand the sheer power we're talking about, just get a load of this. This process isn't about gentle bubbling in a fish tank. No. It's about creating microscopic bubbles that collapse with so much force that they generate tiny hotspots hotter than the surface of the sun. I mean, just let that sink in for a second. That's the mind-blowing power of hydrodynamic cavitation. And the process itself is actually pretty simple. It happens in just 3 steps. First, as water is forced through a narrow point, tiny bubbles, or cavities, are formed. Second, as they travel along, those bubbles get bigger. And third, this is the magic moment, they violently collapse or implode, releasing a massive amount of energy right at that single point. So what does all that energy do? Well, inside this specially designed chamber, called a vortex diode, the water swirls around, creating those bubbles. And when they collapse, they generate localized temperatures around 10,000 Kelvin and pressures of 1,000 atmospheres. That extreme environment physically and chemically shreds any pollutant molecules that happen to be nearby. But that was just punch number 1. The second punch is photocatalysis. You can think of it kind of like a solar panel, but for purification. When light hits a special catalyst material mixed in the water, it creates these powerful oxidizing agents. Think of them like a molecular cleaning crew that hunt down and neutralize any pollutants the bubbles might have missed. Okay, so the theory is powerful, the technology is elegant, but here's the most important question of all. Does it actually work? Let's take a look at the results. This chart shows what happened with a common pollutant from medicine. Now, using just the bubbles, that's the hydrodynamic cavitation, or HC, it degraded about 15% of it. Adding another chemical helped a bit, bumping it to around 31%. But look at that third bar. When you combine the bubbles with the light-activated photocatalysis, bam, it skyrockets to nearly 68% degradation. That is the 1-2 punch in action. So what's the bottom line? Combining these methods gives you over a 200% boost in performance. This slide just sums up the whole journey perfectly. Contaminated wastewater goes in. It gets blasted by this intense process of physical breakup and chemical oxidation. And what comes out is treated water, with the pollutants broken down into harmless little bits. And that brings us to our final big thought. We've just seen a technology that can take on some of the toughest, most stubborn pollutants in our water supply. It's powerful, it's efficient, and it doesn't create a bunch of toxic byproducts. So the question we're left with is this. Could these powerful little microreactors be the key to finally solving our massive macro problem with water pollution?